On Venus, your pan wouldn't have time to heat up. The air around you is already close to 465 degrees Celsius, hot enough to cook the egg before it ever touches the metal. And that is only one planet. Across the solar system, the exact same egg behaves in wildly different ways, shaped entirely by gravity, pressure, and heat. Let's follow it, world by world. Start at home. On Earth, a cracked egg drops in a straight line, hits the pan, and spreads exactly the way you expect. Ordinary, predictable. That's the baseline. Remember how normal this feels because it won't stay that way. On the Moon, there is no air at all. The moment the egg is exposed, the water inside it doesn't simmer. It boils away instantly into the vacuum, pulled out as vapor. What's left dries and freezes in the same breath, because the surface can swing from over 120 degrees Celsius in sunlight to more than 170 below in shadow. And the drop itself takes longer than it should. With only a sixth of Earth's gravity, the egg falls in slow motion, as if the Moon is reluctant to let it hit the pan. Mars creates a different problem entirely. The gravity is still weak, so the egg drifts down gently. But the atmosphere is so thin, less than 1% of Earth's pressure, that water boils at a much lower temperature than usual. Your pan can be technically boiling while barely warm to the touch. The egg white never firms up the way it should. Cooking breakfast here means fighting physics just to get water to behave. Mercury swings the other direction. With almost no atmosphere to hold in heat, the sunlit ground can reach over 430 degrees Celsius. The pan glows before the egg even lands. But step into shadow, and the same spot plunges to nearly 180 below zero. On Mercury, breakfast and a deep freeze exist meters apart from each other. Now the egg leaves solid ground behind completely. Jupiter has no surface to land on, only atmosphere, thickening as you fall. Near the cloud tops, the egg would freeze in the cold outer layers, but drop it further, and rising pressure and heat would eventually crush and vaporize it long before it found anything to rest on. Lightning flickers below in clouds of ammonia, and the winds around you roar loud enough to drown out the sizzle you're imagining. Saturn plays a quieter version of the same trick. It's a world so light for its size that it would float in a bathtub big enough to hold it. Yet the deeper the egg falls into its atmosphere, the more that lightness disappears, replaced by crushing pressure with no floor waiting underneath. Uranus flips the danger to cold. Its cloud tops are the chilliest in the solar system, dropping past 224 degrees below zero. Here, the egg wouldn't cook at all. It would simply freeze solid mid-air, tumbling through a pale blue haze, spinning oddly because the entire planet rotates on its side. Neptune answers with speed instead. The winds here are the fastest recorded anywhere in the solar system, gusting past 2,000 kilometers an hour. The egg wouldn't fall so much as get seized and hurled sideways into a deep blue storm, gone from view before it ever reached an imaginary pan. And now, back to Venus, the true final stop. The pressure at the surface is over 90 times what you feel on Earth, equivalent to standing nearly a kilometer underwater. Combine that with 465-degree heat, and the egg doesn't fry so much as flash cook in a fraction of a second, the shell darkening before it fully leaves your hand. Above you, clouds of sulfuric acid drift across a sky the color of rust. There is no gentler way to say it. Venus doesn't cook breakfast, it erases it. After traveling across every planet, the strangest discovery isn't that eggs cook differently out there. It's that Earth is the only place where the process feels so ordinary we never stop to notice how many conditions, the exact gravity, the exact pressure, the exact heat, had to align perfectly just for breakfast to be boring. Which planet would you actually risk cooking on, Mars or Mercury?